A blessed day to you all and welcome to B2C tutorials once again. Today we want to look at how to read the tables concerning present values and future value. Having that in mind, we discussed in our previous lessons what future value and present value is about. We said to find for future values, you compound the present values, compound the present value. When we say compound, and what does it mean? It means that when you have your present values, you multiply that by 1 plus the discount rate, bracket close, raised to the power n. Then how about to find for present value? We said that for that you discount future value. So either future value is equal to 1 plus r raised to the power n, or this is basically written as future value multiplied by the discounted factor. So 1 over 1 plus r is called discounted factor raised to the power n. So this, the whole of this portion, which is highlighted in the pink, you call it discounted factor, DF, discounted factor. So anytime you multiply a discounted factor by the future value, you get what we call the present value. And then when you multiply 1 plus r raised to the power n by the present value, that is called compounding. So the compounding and then the discounting. So to compound present value, you get future value. And to discount future values, you get present value. That is one. So a clear example is what we took in class the other time, where in a question you realize that they tell us the present value, which is the money today, was say 20,000. The number of years was 6 years. The rate was 10%. And then you've been asked to find for future value. Now, once this comes in mind, you know your formula is present value multiplying 1 plus the 10%. So let me write R. Let me first write the formula. 1 plus R raised to the power n, where we know PV is 20,000. Where you know 1 is still 1, but then R happens to be 10%. And lastly, then n, which is the number of years, represent 6 years. Now, when you do this on your calculator, you expected to get an answer. Now, that is not my focus. Now, you see the one written in the boxed one. This 1 plus r raised to the power n is what we are going to look at using the table. So we'll be considering the table for the future values, and we'll be considering the table for the present values, and we'll solve some examples to sort ourselves out. All right. So quickly, let's go to the table and let's explain. So these 1 over 1 plus r raised to the power n is what we are going to look at from the table. So let's go to the table quickly. Now the table begins with f future value. So you see either FV or you see future value. It means that whenever you are asked to find for it, you use, whenever you're asked to find for a future value, use this table. Now, how do we rate this table? These are the rates, the percentage rates that you see, the 10%, 6%. These are the rates you see. So it is dependent on the type of table you have been provided with. But all you need to understand is that this stands in for the rate. And these are the number of years. So assuming a question tells you to find future value, and then it has given you present value, say present value of 10,000. It has given you the rate of, say, 8%, and it has given you, say, the number of years to be 6 years. Now, this is what you do. You go to the 8% category or the column for 8% and trace the 6 years, the number of years, 6 years, to the 8%. Okay, so when I trace it down to the 8%, it is this figure that I find. So now 1.5869 becomes what I'm going to multiply the present value. So the formula that states that future value is equal to present value multiplying 1 plus r raised to the power n. This 1 plus r raised to the power n is what they've already solved for you. So if you're able to pick this 1.5869, multiply that 1.5869 by the present value of the 10,000, and then you get your answer with respect to using the table. Now, if you are doubting what the table is giving you, you can just substitute this formula into this and see what you get. But then this is how we solve this question. So you pick the present value of the 10,000 and multiply it by what the table is giving you. The table says that at 8% year 6, the figure is 1.5869, and then your final answer will be there. So 10,000 by 1.5869 gives you 15,869. So that answers the question using the table. But then if you were not using the table, you would have done 10,000 multiplying 1 plus 8%. So this is using calculator, 8% raised to the power 6 years. And we are saying that this is how we read it. The 1 plus 8% raised to the power 6 is read on the table by first picking out the rate with the rate in the question and trace it to the number of years and select that. So assuming it was not 8% and then it was not 6 years, and let's say it is we have the number of years to be say the number of years to be 20 years. So number of years is 20 years. And the rate is, say, 14%. So quickly, I go to the 14% column, which is this column, and trace it down to 20 years. Now, this is the 20th year. So 20th year on the 14th column is 113.743. So I'll be multiplying 10,000 by 13.4743, sorry, 743, and that is also going to give me 137,430. So this is what we are going to get when the rate increases. So all you need to understand is that this formula that you see, it is the ones in the bracket, 1 plus r raised to the power m. That is what you find on the graph. So the whole table here represents the 1 plus r raised to the power n. Once you find the rate, trace it to the number of years, pick that figure, it changes or substitutes the whole of this and multiply it by the present value. I'll use that to solve a question for you, and then we'll all follow suitly. All right. So having said that, this is a future value for 1 cedi. So it is assumed that 1 cedi's future values are there. So if you multiply 1 cedi by the number of the amount given you, you should be able to arrive at the final answer. Now, this is also for future values of annuity, and then it is also standing in the gap for this is annuity. Annuity, that is when it has to do with constant payment. So at your level, this is what you need to know: future values of 1 cedi interest rate. And when I say annuity, the payment, which is C, is constant for a period of time. So that is where we'll be using this table. So this is not meant for you. Let's go to the next one, which also talks about present value of 1 cedi. Now, how do we find present value? You'd all agree with me that present value is equal to future value over 1 plus R raised to the power n. And I said this can be written as, so we can rewrite this as the future value alone multiplying what we call the discounted factor 1 over 1 plus R raised to the power n. Now, on the present value table, this 1 over 1 plus R raised to the power n is what you see in the table. So the what is in the table is the 1 over the 1 plus the rate R raised to the power n. So if my rate is, say, 8%, and the number of years is 10 years, then what is the discounted factor? 10 years. What then is the discounted factor? I'll go to the 8% category again, and I'll go to the number of years, which is 10, and I'll trace it. And that is 0.4632. So the whole of 1 over 1 plus R raised to the power n is the one that we found. And then you just multiply that final answer by the future value. So let's take an example again. So in this example, I'll be doing it on your extreme left. So in a question that we've been giving future value to be, say, 50,000, and we've been given our rate to be 10%, or say 12%. Let me put 12%. And the number of years is 4. And then I've been asked to find the present value when future value is 50,000. The rate is 12%, and the number of years is 4. And I've been tasked to use the table. Now, the formula that I have written here, future value multiply 1 over 1 plus R raised to the power n. I'll go to 12% column, and then I'll pick for year 4, and then select what is there. So 12% year 4 is basically this figure, 0.6355. So it is going to be the 50,000 using this formula. The 50,000 multiplying the 0.6355, and that would give us our present value. Now, if you doubt your answer, you can just try using the calculator to solve it and see. So 50,000 multiplied by 0.6355, that is 31,000. So if someone is promising to give you 50,000 in 4 years' time at a rate of 12%, and you're asked to find the present value of that money, the person is expected to give you 31,775 before at the end of the 4th year, you can get the 50,000 Ghana cedis. That is the meaning of the present value. Okay, so that explains the question. Now, if you're in doubt, you can just prove your answer by having 50,000 divided by 1 plus 12% raised to the power 4 years, and confirm if your answer would not be the same as this, or it would not be so close to it. Because this one, they have round off the numbers to the nearest 4 decimal places. Be careful. not to use this if you've been instructed to use the table. If you've been instructed to use the table, please go according to what the table has given. If not, when you do this, you'll be getting some decimals, which is going to go beyond what the table figure will give you exactly. So that is one of the things that I want to let you know when it comes to reading of the table. If you still think you are challenged, you can reach out to any of these numbers on WhatsApp and then let's discuss the 050-765-2761 or 053-9948-466. We can talk, and then maybe if you seek some clarification, I'll do well to explain to you. Okay, having said that, let us try and then do some question solution and see if we can do it. All right, so let us solve this question using both the table and the formula. Example, you've already used the formula in our previous video, so I would expect I'll just do one, and then the remaining I'll use the tables to solve it. Your great aunt, Matilda, put some money in an account for you on the day you were born. The account pays 8% interest per year. On your 21st birthday, the account balance was 5033.83. This means that the amount of money your great aunt Matilda originally put in the account is close to. So this question is asking you to do present value. And we all believe that present value is equal to future value over 1 plus r raised to the power number of years, or present value is equal to future value multiplied by 1 over 1 plus r raised to the power n. So if you do for so this happens to be the future value. Now the rate in the question is 8%, and the number of years n is 21 years. So let's see if we can get 21 and 8% on our table. Then we translate it into writing. So the first thing is that we have been asked to find present value, and we believe that present value is equal to future value multiplied by the discounted factor 1 plus r raised to the power n. And then in the question, future value was equal to 5033.83, 5033.83. Then we have the rate to be 8%, and the number of years to be 21, and to be 21 years. Now let us try and put this using the table. So basically, the 1 over 1 plus r raised to the power n can be found on the table. Let's go to the table and see if we can find a table. So this is present value. This is the 8%, but then we don't have 21 years. So it will be a bit of a challenge here. But then if you will be asked to, they'll put it in 21 years for you, and then you'd find it. So assuming the question was 20%, let's assume the question is 20%. So we are assuming that the question we have here says 20%. 20 years, sorry, 20 years, not 20%. Assuming the question says 20 years. So we will be using 20 years in the question. When we are done, we'll use the calculator to find it and see if we'll be around the same answer. So 20 years. Now, quickly, I know on my table 8% and 20 years. This is 20 years, right? Another 8%, and the figure is a 0.2145. So my discounted factor which is the DF, is 0.245. And then my future value still remains the 5033.83. So I would only multiply the future value by the discounted factor to get my final answer. So 5033.83 multiplied by 0.245. And our final answer will be that of 0.245 times 5033.83. That is 1233.28. 1233 is in decimals. 1233.89. 0.29, sorry. 0.29. Now this gives me my present value using the table. Now, how about using the formula? So using the formula, it would have been present value equal to, future value, Fn times 1 will give me Fn. That is why normally you write it straight. But then you can decide to write 5033.83. So it would have been 5033.83 times 1 over, and I'm saying this 5.033 times 1 will give you the same. That is why normally we write just this 5033.83 over the 1 plus the 8% raised to the power 20. So when you do this, you expect it to get a minute whilst I do that on the calculator. So that is 1 plus 8% raised to the power 20. That should be around 1. Did we read the writing on the graph? Let's go again. 8%. Let's pick the 25. Oh, sorry. So it was 2145, not 20242. No. So I picked wrongly. It was 2145. So let us change it to 2145 using the table. It was 0202145 0245. This right one. So the discounted factor is expected to be these rather on the graph. Let's go again and then see it out for ourselves. So this is it. 2145, not 245. So let's redo the computation before we come to the graph. So 5033 point. Yes, so it should have been 1079.76. And if you use the table, if you use the calculator to, you get 1079.999 going. So this would be the calculator's answer. and this would be using a table because the table has run it off. So you realize that they are all in the same category, 1079, 1079. It tells you that either you use the calculator or you use the uh formula you're right, but then be open-minded because the question can tell you use the calculator and you don't have any option that you use the calculator. The question can also tell you use the table and then you are supposed to come and read from the table. Please don't be like me who picked the wrong figure when I was doing the computation. Please pick the right figure and then you'll be sorted out. So we'll be hoping to solve more questions around this anytime we get the opportunity to meet. Until then, have a blessed time and a bye-bye.